U.S. Army taps a West Point cadet to solve a costly drone problem. Alex's work and contributions look at moving away from simply targeting the nearest threat. Instead, it focuses on intelligently clustering targets and selecting engagement strategies based on the threat's composition and our system/munitions capabilities. By factoring in multiple variables, the goal is to optimize the time spent engaging a massive U.S. threats to maximize U.S. defeat with a single system, said Sosa. That shift matters because a system programmed to simply shoot at whatever drone is closest can waste time and munitions on low-value targets, while a more dangerous threat slips past unaddressed. Anteen's algorithms instead analyze incoming data, including a drone's speed, altitude, payload capacity, and how densely the drones are clustered together to calculate which countermeasure fits each threat best. Depending on the situation, that could mean a kinetic interceptor, a physical projectile fired to destroy the drone directly, electronic warfare that jams or hijacks the drone's control signals, or directed energy weapons that use lasers or focused radio waves to disable a target's electronics, all with the goal of preserving expensive, high-value munitions for genuinely dangerous threats while handling lower-tier drones with cheaper options. This work builds on years of Armaments Center research into exactly this kind of layered, cost-conscious drone defense. The Defense blog has previously reported on the center's parallel effort developing modular lethal payloads for the Army's own armed drones, an initiative the center has pursued using design processes it originally built for the widely adopted Picatinny rail, the mounting system found on rifles across the U.S. military and much of the world. The Armaments Center has also partnered with private industry on emerging counter-drone technology, signing a 3-year research agreement with the company Auriga Space to develop electromagnetic accelerators, weapons that fire interceptors using magnetic force rather than gunpowder or rocket fuel, specifically to address what officials have described as a growing strain on America's traditional missile stockpiles. Anteen's academic background positions him well for this kind of work. He is majoring in operations research at West Point, an interdisciplinary field jointly run by the Academy's Department of Mathematical Sciences and Department of Systems Engineering that trains cadets to apply quantitative methods, data science, and mathematical modeling to optimize military decisions involving scarce resources. Cadets in the program take a demanding course load of advanced mathematics, statistics, and engineering, and they gain hands-on experience translating real-world military problems into mathematical models through capstone research projects, exactly the kind of work Anteen completed and presented at the end of his 3-week assignment at Picatinny Arsenal. The algorithms remain in the simulation and modeling phase, according to the report, currently being tested against complex, multi-axis drone swarm scenarios designed to mimic how a real attack might unfold from multiple directions at once. Early results reportedly point to meaningful gains in how efficiently a defense system engages incoming threats, along with a reduction in how quickly localized air defense magazines, the limited stock of interceptor munitions a given unit has on hand, get depleted during an engagement.